need to validate JWT tokens in FastMCP using a fixed public key, without relying on dynamic key endpoints. You'll see how to configure a JWTVerifier with a static RSA public key, ensuring only tokens signed by your trusted issuer, and no one else can access your protected API. This approach is perfect for controlled environments where key rotation isn't required. From FastMCP, import FastMCP. From FastMCP, server, auth, providers, JWT import JWTVerifier. Hash use a static public key for token verification. Public key PEM equals begin public key. MIB, IJ, and BGKQHKI G9, W0 bake FAKEK, 8 AMIB CGK KKIA. End public key. Verifier equals JWT verifier. Public key equals public key PEM. Issuer equals https://auth yourcompany.com. Audience equals MCP production API. MCP equals FastMCP. Name equals protected API. Auth equals verifier. This demonstrates the externalized authentication pattern, where token validation is decoupled from the core application logic. The concept relies on treating your service as a pure resource server that validates tokens issued by a separate authentication authority, rather than handling user credentials directly. What makes this distinctive is the clear separation between identity management, handled by the token issuer, and resource access, handled by your MCP server. The pattern works by establishing a trust relationship through cryptographic verification. Your server receives tokens containing claims about the user's identity and permissions, then validates them using public keys or introspection endpoints, without needing to understand how those tokens were originally issued. This creates a declarative security model where access rules are enforced based on token contents, while the actual authentication flow remains externalized to specialized services. This approach matters because it enables clean separation of concerns in distributed systems. You can integrate with existing authentication infrastructure, like OAuth providers or internal auth services, without coupling your application to specific identity protocols. It's particularly valuable in microservices architectures, where multiple services need to validate tokens from a central authority, or when you need to enforce consistent security policies across different types of clients. The trade-off is that your server becomes dependent on the token issuer's availability and key management practices. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It handles the heavy lifting of exposing Python functions as structured tools for AI models, managing serialization, validation, and transport. From FastMCP, server, auth, providers, JWT import JWTVerifier. Imports JWTVerifier, the authentication provider that validates JWT tokens against your public key. This handles the security layer for your FastMCP API, ensuring only properly signed tokens can access protected endpoints. Hash use a static public key for token verification. Public key PEM equals begin public key. This defines a static PM-encoded public key for JWT verification. Using a hard-coded key simplifies deployment, but requires secure key rotation processes, as compromised keys can't be revoked without code changes. This is the public half of an asymmetric key pair used to verify token signatures. MIB, IJ, and BGKQHKI G9, W0 bake FAKEK, 8 AMIB CGK KKIA. This is a PM-encoded RSA public key used for JWT signature verification. It ensures only tokens signed by the matching private key are accepted preventing spoofed authentication. The static key approach works for production when key rotation is handled externally. End public key. This terminates the PM-encoded public key block. The closing delimiter ensures the key parser recognizes the complete key boundary, preventing malformed key errors during JWT verification. Verifier equals JWTVerifier. This instantiates a JWTVerifier for token-based authentication. It validates incoming requests by checking cryptographic signatures and token claims, ensuring only authorized clients can access your API. This is the standard pattern for securing FastMCP endpoints with JWT. Public key equals public key pen. This passes the public key in PEM format for JWT signature verification. It ensures only tokens signed by the matching private key are accepted, preventing spoofed authentication requests. The key must match what your identity provider uses to sign tokens. Issuer equals https://auth yourcompany.com. The issuer parameter validates the token's origin, ensuring only tokens from your authentication server at https://auth yourcompany.com are accepted. This prevents spoofing attacks by rejecting tokens from untrusted sources. Standard JWT security practice. Audience equals MCP production API. The audience parameter enforces token validation against a specific target service. It prevents token replay attacks by ensuring JWTs are only valid for this exact API, not other services in your ecosystem. This is a standard OAuth 2 security practice for service-to-service authentication. This closing parenthesis finalizes the JWTVerifier instantiation, locking in the JWT validation configuration. It ensures all subsequent API calls through FastMCP will enforce this authentication scheme, rejecting any tokens that fail verification against the specified public key, issuer, and audience. MCP equals FastMCP. Name equals protected API. Auth equals verifier. This instantiates the FastMCP server with JWT authentication enforced. The auth equals verifier parameter locks down all endpoints to require valid tokens, using the public key and issuer audience constraints we configured earlier. This is the standard pattern for securing FastMCP APIs in production. JWT verification pattern. This static public key approach demonstrates FastMCP's flexible authentication, where token validation happens locally without network calls to the issuer. The public key must exactly match the issuer's private key, or all validations will silently fail with no helpful error messages. Always test with invalid tokens early to catch configuration mismatches before production.
The key that never changes validates every token that does.